Oh, hey there. Today we are going to come back to some word problems. Really what we're doing today, you already know how to do, you did it with addition. You'll just see that some of these situations start off as a subtraction problem, so you're going to learn how to model subtraction problems, and there will of course still be addition problems in here as well, and then solve those situations. So make sure you have, first of all, we still have the last couple of questions on page 8 to do. So if you'll get out page 8 first, and we're going to kind of lead in with those last couple questions, and then we will move on to page 9. So everybody grab page 8, grab a pen, pencils, whatever you're going to write with, and let's be ready to go. All right, here I am on the bottom of page 8. It says, set up a subtraction problem to answer each question. So we did this with addition. Addition is obviously going to be a play still here, because what does every subtraction problem turn into? Oh yeah, addition, okay? But these situations, these last couple down here are a lot of what the new type are for you to set up and deal with in 7th grade. And we've been working on problems like this all the way since the beginning of this subtraction stuff when we looked at extreme temperatures on the states. So right here, number 10, find the change in temperature if the temperature rises from negative 18 degrees, that means the low it was at was negative 18, to positive 15. So this really is just like the extreme temperatures task we started with. So I am going to start with the positive value. It often makes more sense that way, and you'll see why. I want to know the difference. The change in temperature is another way of asking for the difference. How far apart are they? So difference does mean subtract, but what am I subtracting? I am subtracting a negative, which is something that if I said that to you, over the summer or something, or last year, you would have been like, what are we doing? What is that? But now you're so used to it, you know exactly what to do. You know you copy the first one, you know you change the action to addition, and you change that negative 18 to the opposite, positive 18. You now know, hopefully you're starting to get really good at the fact that minusing a negative is just adding a positive. 15 minus negative 18 is really just 15 plus 18. And now all I have to do is add those. It's same signs add, keep the common sign, but that's also just kind of elementary positive numbers we've worked with for a long time. So 15 plus 18 is 33 degrees Fahrenheit. Now let's take this back to the question. What did it ask? The temperature rises. So that was a change of 33 degrees. If you were from negative 18 all the way up to 15, that temperature increased. And we can write that, increased. It was an increased change of 33 degrees. The change went up. It was here, went all the way up here. Okay, so that was a change of 33 degrees. Let's look at number 11. An airplane flies at an altitude of 26,000 feet. A submarine dives to a depth of 700 feet below sea level. A lot of context to put together there, a lot of context clues. But below sea level definitely tells me that this is a negative value. And look at this right here. What is the difference in their elevations? Well, that's going to look a lot like this one then, isn't it? I have an airplane that's way up high at 26,000 feet. I'm looking for the difference, so I'm going to subtract, but I'm subtracting a negative. No big thing. We know what that means. We know subtracting a negative is really adding a positive. And the difference in their elevations is they are 26,700 feet apart from each other. That's the difference in their elevations. That's how far apart they are. Okay, so we got these last couple questions down here. These are really the main new type of problems that you need to be able to model with mathematics in 7th grade. Turn your attention to page 9. And page 9 really mixes it all up. It's called using addition and subtraction to solve problems. So here's what I'm going to have you do, because really we've practiced this a lot. We've worked through this. I'm going to help you fill in the blanks on the top, okay? First thing you need to know right here on the fill in the blanks, distance between 2 points. Distance is always positive. If you're wondering why or what we mean by that, like if somebody asks you, how far away do you live from, how far is your house from the school? You'd say like, I don't know, 2.5 miles. You would never say negative 2.5 miles because as far as distance goes, that doesn't mean anything, right? If you say, how far apart are you from me? How far away are you from me? You're 3 feet from me. You're 6 feet from me because we're socially distancing. You would never say you're negative 6 feet from me. What does that even mean? That doesn't mean anything. Distance is positive. Distance is positive. So distance between any 2 points is always positive. So those questions like how far apart, what's the difference between the airplane and the submarine? That's distance. So the answer was positive. It wouldn't make sense to call it negative. Now, another thing you run into, so distance is one important thing that you run into with subtraction modeling. Another thing you run into is how much things change. And change is interesting. So that was like the change in temperature. Change can actually be positive or negative. And it really depends on whether something is changing with an increase or a decrease. So remember, like on question number 10 here, our answer was definitely positive because that was an increased change. The temperature went from really low to really high. If it were changing the other way, the way we would show that mathematically is we would make it a negative. So here's what you guys are going to do. There are 6 problems here. It says use what you know about rational numbers to solve each problem. Now, just like when we did this before and we talked about when do I use a calculator or not, the main key here, the most important part of the standard to me is that you can do what we call modeling with mathematics. That means, can you read this problem? Can you set up an addition or subtraction problem? And then can you solve it? And if you need a calculator for that solving it part, that's totally fine with me, but I need to see your setup. I need to see the addition or subtraction problem that you're setting up before you tell me an answer. So with that in mind, you guys are actually going to pause the video here and you're going to try these 6 problems. Now, if there's one that you read that you're just like, whoa, I have no idea what that's saying, skip it and try another one. You may not be able to do all 6 of these, and that's okay. See how many you can do, see how many you can complete, and then come back to the video and see how you did. So right now, pause. But then you're gonna come back, okay? But pause me right now. All right, guys, let's see how we did. What you should be doing at this point, I'm gonna show you one problem at a time so that you don't get overwhelmed by all of it. I show you here my setup, change in the hiker's elevation. The low sea level is negative. So there's my setup. Then I changed it to addition, and then I solved it. And I'll tell you for this one, I did not use a calculator. I didn't need one for that. But I absolutely needed to show my setup, show how I changed it, show my answer. The change was 780 feet. And if there's any of these that as I'm going through, if you mess something up and you can see, oh, I can see what mistake I made, right, just fix it on your notes and move on. If you're looking at mine and you're looking at yours and you're like, I don't understand what you're doing there, Miss McGowan, that's where you ask, okay? If you're here in class, come over and ask me. If you're at home, email me and I will respond. But if you don't understand something that I go over on these, make sure you ask. Here's number 2. How far does Luke have to walk? That's a distance question. And I showed it this way. A lot of you probably flipped it around even. And I'm going to show you one more setup. If you did it like this, 4.75 minus -5, guess what? That would turn into 4.75 plus 5, which still equals 9.75. It doesn't really matter as for this particular problem as long as you remember that distance is positive. So when I'm done, my answer is going to be positive because a negative distance doesn't make any sense. So regardless of which way you set it up, make your final answer positive because it's distance. Okay, here we go, number 3. What? That question looks almost the same as what we just did, but do you see the difference? The temperature is falling now. Instead of going from the low to the high, it started high and it's going low. So this is an example of when change is negative. It's a negative because the temperature dropped. And that's how we show that mathematically. So we just put a negative on it. All right, number 4. Distance will be positive no matter which way you set it up. Make your answer positive Why? Because distance is positive. Negative distance doesn't mean anything. It doesn't make sense. Okay, here we go, question 5. And of course you can pause at any point. If you're like, I'm still writing that down, Miss McGowan, just pause me and keep writing. This one just went to an addition problem. -2 plus 1.5 plus 2.7. There's a subtraction, or you could just write it like this right away, because we know it's going to turn to that anyway. And then you could type this one in a calculator, do it out by hand. It's actually negative because this is not a change or distance question. This was just what was the temperature at that point, and the temperature was at -2.5 degrees. So that was just really like a lot like the addition problems we've already done. And last one, number 6. This is another one that's really a lot like what we did last standard. Set it up, use a calculator if you need to, but I want to see you model the problem. Some people start like this and make this subtraction and then change it. Some people start right like this. Either way is excellent. Okay, you are going to practice some modeling mathematics situations with subtraction problems. If you have any questions, let me know. Give your practice a try.